Today's lesson on chemical nomenclature is going to focus on covalent compounds. You will need to be able to recognize the difference between covalent compounds and ionic compounds. And this you already know how to do. Covalent compounds contain non-metal elements, and you will be looking for those non-metal elements and no metals in your formula or in the name that is given. When you are writing the actual name of your compound, we use lowercase letters as often as possible. Unless you were starting a sentence with the name of the compound, you'd capitalize it like any other letter or any other word. When we name covalent compounds, the system is always the same. We write the full name of the first element. And for the second element, we will write the name of it, but we chop off a few letters and we add the suffix IDE. Now, how many letters do you chop off? Sometimes this is hard to know. The best way to get comfortable with this is just to practice this and learn which elements take on the suffix and how many letters to drop off of each elemental name. The one thing that we use in covalent compound nomenclature is we use the prefix system. So we have a system of prefixes that indicate the number of atoms, and we use a system that goes from 1 atom, which is mono, all the way up to 10 atoms, which is deca. And you are expected to know these prefixes. When we use the prefix mono, we tend to only use it on the second element if needed. And this is sometimes tricky. I don't know why, but we never use the term or the prefix mono on the first element if there is only one of them. So when we look at the examples that are listed, for CO2, we have 1 atom of carbon. However, we're not going to use that prefix mono, right? Because it's not the second element, it's the first one. So we're just going to write carbon, full name. And then oxygen is our second element. There are 2 of them. We're going to use the prefix for 2, which is di. And then we're going to add that IDE suffix to oxygen, and we're going to call it oxide. The next compound right here is commonly called hydrazine. This is a rocket fuel, but to name it based on our nomenclature rules, we have 2 nitrogens. So we're going to use the prefix di, and we write the full name of the first element, dinitrogen. And then the prefix for 4 is tetra. We have tetra hydrogens, right? And we have to add that IDE suffix, so we call this tetrahydride. The next one, PCl3, phosphorus, there's only 1, so we leave the mono off of the first element, so phosphorus. And then we have 3 chlorines, so we call this trichloride. And then the last example that we have, this is actually the name for, or the formula for butane. This is a type of fuel. But if we name it according to nomenclature rules, we call this tetracarbon, because there's 4 of them, and we use the full name. And then for the second element, we add that "ide" suffix. We have 10 hydrogens, so we call it decahydride. When we create the chemical formula for a covalent molecule or a covalent compound, we just simply indicate the number of atoms of each element using prefixes. And the very important part is that we do not reduce the charges, okay, or we do not reduce the numbers, the subscripts of our atoms, and we do not use the crisscross rule, okay? So we should not be bringing these numbers over to the other element as you would with ionics. So when I see carbon tetrachloride, that tells me that I have 1 carbon. Tetra is the prefix for 4. So I have a chlorine and I have 4 of them. Okay, so carbon tetrachloride. If I go over, I see nitrogen monoxide. That tells me I have 1 nitrogen. It also tells me I have 1 oxygen. So there's my formula. No crisscross rule, and again, not reducing. Here's disulfur, so it's telling me I have 2 sulfurs, and I have a tetrafluoride. I have fluorine, and I have 4 of them, and I do not reduce those numbers in any way. And then lastly, I have tricarbon, so I have 3 carbons, octahydride, which is an 8, and there's your formula for that molecule.